Hello everyone, welcome back to the series. Today we're going to be design the insurance SaaS product. So this will be the large scale application where we have the data around billions of data and we will design that different services and we'll discuss the AWS different services which will going to be used in this system design part. I will show you the live demo of doing all of these services using the all of the services in this video, like so that you can use that on the proper way, and I will explain you the basic concept of the each services, what you can achieve from that services, how we can integrate that particular service in our real time application, how we're going to be implement that. All of these things we're going to be covered in this video. So stay tuned. Let's start with the very first. First, we'll have to design the structure of the insurance as product. Okay. So we'll design very basic structure first of all, and then we'll check the which problem we're going to be face. Okay. So I will start the design. First of all, we need the API gateway. Okay, so this will be the API gateway, which have the load balancer. Okay, and this will be connect with the other service, which will the important, which called the auth service. Okay, so there will be the one more service, which will be the important service. Let me copy this below template so that we can have the same kind of structured. Okay, and we'll have the multiple services. I will name it properly. Just to write this. Okay, so this service will be the reporting service, report service. This will be the onboard service, onboard service, and this will be the claim service. As it is claim service, we follow the single responsibility principle. Each service have to follow the single responsibility. Okay, and there will be the one more service which called the indoors, uh, or what we can say, we'll give the name, proper name to that service, which called the uh, bind insure. What exactly means, we called that the endorsement, but I will tell you, I will simply write the bind insurance service. Okay, and one of the most important service will be the auth service, which is more important, and we need that. Why I kept this auth service outside the load balancer, I will let you know later on. But now the large scale enterprise application, we generally keep the auth server outside the API load balancer and API gateway. But you can add that into the load balancer if you have the small application. Okay, once we have the all services, we're going to have the different database for the each service, some of the services. Okay, so this report service have the different database. Why I make this? Because we are not relying on the same database. Okay, and I will name as a report db. Once we have this report db, we will have, let me do a little bit. Okay, so this db I will copy, and we do have the onboard db for the onboarding service. Okay, and we'll do have the, let me do, and we'll do have the sorry, different db, this common db for the both service. Why I kept this common, so I will let you know why I kept this common db for the both service. And we'll do have the one db for this service. I will name it as a properly, just allow me a while. Okay, so I will name as the onboard db, onboard db. Okay, then we will have the common db. Okay, once we have the common db, let me do a little bit strength. Okay, once we have the common db, we'll do have the auth db or user db, which will going to be we will going to be store the user data. Okay, so now once we have these, now we are pretty much like completed our architecture. But now there is a lot of problems. What, we are tightly coupled with these services, and let's see sometime what happened. Onboard service wanted to be communicate with the auth service as well and other services. That time we have to take a decision. Okay, so before we complete, we need more services, which called the notification service. Service, why I kept a notification service, uh, sorry, service here, because every time once we render the report, sometime we need the reporting service as well. Okay, let me scroll it little bit down. Okay, so what I mean to say notification service is dependent on the each I let make a little bit here so that you can understand the things properly. Let me extend little bit to this, to this. Okay, so now my notification service will be called each of these. Okay, Once we onboarded, some bind happened, we used to call the notification service, and blah blah blah. So this is too heavy, you know. Now my in this case, almost five services calling on the notification service. So what happened? My five services is calling, and we do have a lot of users calling this notification service a lot of time. So what will happen? It will going to be the fail in this case, because if my notification service is down or something happens, so user will get that latency as well. Okay, so in this case, that when we calling the notification service, we mostly add the queuing mechanism in between. We do the asynchronous processes in this case. So we don't care about the notification at that moment. We don't need the response of the notification service. You do your work and then response whenever you need. So that time we mostly use the queue. Okay, so rather than doing directly into this service, we'll do this as a queue. In AWS, we use the SQS. It's a queue, and once we send that particular notification in queue, we'll do have the notification service. Oh yeah, okay, notification service. Okay, so yeah, will be the notification service, and once we have the notification service, all one by one notification will triggered and it's sent to the proper user. Okay, so this is the process we're going to do now. Major important part, this DB is interconnected. You can call it whenever you want. Okay, so we have the users which is calling to the IP gateway, and we will not disclose this services for to the services for to the public. Why? Not because we don't want it to be access this particular service directly to outside of the user. So in if you are using the if you know the Docker, we can have the bind port in Dockers. We will not going to disclose that bind port. Okay, so there is a functionality we can achieve via this. So we're going to disclose and we're going to be public the API gateways port only, not any other ports. And how, let's see, then how we're going to be communicate with the each other service? We'll directly communicate by the name. Let's see in let okay, so let's see, I wanted to call the reporting service. I will call the report service HTTP then report. Internally, we're going to be called the, let's see, my port will be the 3000 in this case. So I will call this, but not public will call. My load balancer will call this to the this, and this service will return the response. I will return to the users through the this. So how we can do that? So we used to write the code in Java. We mostly write code in the profile where we uh, add the dependency called the load balancer dependency, and where we can add the profile YML file, and we route the proper request. Let's see, my request is coming on the report service. So it means that I used to route that particular service to this particular route based on this service name. In case, let's see, other case onboard. So I will reroute that particular service to the onboard service like this other as well. Okay. So you got this. We will going to be use each and every services from the Amazon. They have given a lot of services we're going to be used. Now major part. Let's see. We have the important part over here. We have the report service. Let's consider the report service, and I do have the report database now. But our main database is this and this. Okay, and we want data over here. Okay, understand? Now problem is that how you going to be design and how you going to be update this database now. Okay, understood you? Are you understanding my problem? So you have different database, so you have to update this. There are a lot of way to do that, but we're going to be discuss this optimum way, and it should be scalable and lot of enterprise application and enterprise company using that. So we're going to be discuss that. Okay, so now let's see, we're going to be use the Kafka in between. Okay, let me introduce the Kafka. I will let you know what exactly Kafka mean. I will show the Kafka as well. Kafka is a event driven and event streaming application where you can send the event and receive the event. Okay, now if suppose my user data updated, I will send the event to the Kafka. So let me little bit do a vertical to the my Kafka. Kafka, if you don't know about the Kafka, just follow my one of the video. I have explained a lot in that Kafka. So I will going to be send the event to the Kafka every time. Okay. So my drawing is little bit what we can say architecture, and it's not too good. Just follow what I'm doing. Okay. So we'll call the event. This is the Kafka. Kafka will be the standalone servers, and it have the different brokers so that we will not lose any event, and it's highly available. Once we receive the Kafka, we have the event. Okay, so now I wanted to the update the database. So how will it be update? I will add the worker over here. Okay, now I will go up and I will add the worker over here. My worker, I will let you know what worker will going to be do. Worker here, let's see, worker 1, worker 2, worker 3. Okay, worker 1, worker 2, worker 3. Okay, so this worker 1 2 worker 3 and worker 1. Okay, so these are the worker which will going to be run in background, and there might be a lot of workers. So it depend on your application. But take insurance, we have the multiple worker in background running. Once we receive the any event related to the uh, any event related to the report. So we have the different logic and single responsibility functions. We consume that particular event on the different worker. So each workers do the its job. Once they completed the job, we send the file. Before we send the file into the S3, I just wanted to tell one things. We will going to use the asynchronous processes because we don't want it to be fail any and data fail anywhere and data inconsistency in the application. I will go a little bit of once my one worker done works, I will going to be put my file in S3. Okay, so S3 have the different algorithm like, but I will not going to discuss. I will explain you that services in which it will help you in for the interview. Someone asks you the what exactly S3 glance here and all, and how we can archive the any bucket. Okay, once we receive these files in S3 on different location, let's see somewhere I do have the location. Let me write somewhere else. Inside the S3, we do have the Shubham, V1. Okay. Then we do have the location Shubham, then V2. Okay. So once we receive the S3 file in S3 and we located that particular file, any format, that might be the S3 or any other. Okay. So what we're going to be do, we will going to be update, we're going to trigger the event from this. Okay. So how we're going to be subscribe this path, and once someone push the any file on this location, we're going to be trigger that one event. So in AWS, that we can subscribe the particular class path, S3 path and source path normally. So someone s- send the any file on this particular path, we're going to consume, we're going to trigger one event on the SNS. It's as what SNS is. SNS is the notification service where we send the notification. Okay, once we receive the notification on this SNS, let's see ABC notification. Once we got the notification, what we're going to do, we're going to be send this particular notification in the queue. Why I added the queue, AWS queue? So normally in AWS we use the AWS SQS. SQS is simple queue service. Okay, so why we added the queue in between the our processing? Because there might be a chance a lot of files is coming and a lot of notification is coming. So that time we don't want it to be a lose any failure. So that's why we use the SQS in between the lambda, and then we will going to be use the lambda for lambda here. And once we receive any event in SQS, lambda will consume that. Once the lambda consume that, we're going to send that particular event in the glue. So ETL glue is a very famous and very important process in the AWS. We generally call ETL job, and once we did the all things, process the file, we're going to push that particular file in S3 bucket, S3 bucket in the FAQ format, S3 bucket in the FAQ format. So this file will be the .p uh, FAQ format. So this file is will consume the other which called the which called the which will consume the clore. And once we have the clore, and we're going to send the all data in the glue catalog, which is the catalog, so that anyone and our internal stakeholder can the query it like simple query, just like SQL query, or we can get the data and send it to, we can process the data and we're going to be send this data. Let me draw a little bit. Okay, so our glue data will be consumed, or we can push that data into DB. We can add the lambda or some other function over here and consume that data, required data in database. Okay, so this will be the flow, and that this will solve the our reporting data problem, and this will process all the data in different sequence. You can see, or in this case, I use the real-time Kafka notification system, but some company do the use the batch processing or scheduler for to do these type of work. But in real time, application and you want real-time dashboard and real-time all of these things, so that time we have to use this kind of architecture. Okay, now we solve the reporting problem and other as well. So this is pretty much about the uh, architecture. Okay, so let me jump into the AWS portal. As I said, what we are going to be use, I have mentioned the EC2 to Athena. Okay, so for this we're going to be use the Amazon load balancer. So